Hi, my name is Rex Pruitt. I am the Hadoop Adoption Technical Advisor, and I work in the Customer Success Organization at SAS as a systems engineer. In this video presentation about how SAS interacts with Hadoop, we'll be talking about the best practices for those SAS interactions. In a nutshell, these are the top 5 best practices that I have encountered with SAS users over the past 2 years in working with them on their use cases. Number 1, having the data formatted for SAS compatibility at the time the data is placed in Hadoop is a critical best practice. Now, this will require collaboration with your Hadoop administrator, your SAS administrator, and a data management team if there is a team that does separate functions for landing the data in Hadoop. The reason this is important is because of the string types in Hive that cause a very significant issue addressed in item number 4. The best practice here, again, is to have that collaboration and placing the data in Hadoop in a format that's compatible with SAS. Number 2 would be performing as much data manipulation as possible in the Hadoop cluster. In other videos where I've talked about these interactions, the primary focus is to move all the processing into the Hadoop cluster and then only return the result set, which is a subset of what's going on in Hadoop, back over to the SAS server for further analytics through the creation of reports or predictive models. Number 3 is when developing SAS projects, or maybe you're migrating code that was used in other data sources, it'd be important to make sure that the proper functions and formats are utilized. There's a passing SAS functions to Hadoop section in the user's guides and in our support.sas.com reference materials, as well as data types for Hadoop. Number 4 is using the dbmax underscore text equal and or the dba SAS type equal live name dataset options. And the reason one would use these is if you're connecting to a data set that's been placed in Hadoop by somebody who wasn't thinking about or considering the interaction with SAS, they probably placed the data there with a string format. This creates the 32,767 byte column. And if there are hundreds of columns on your data set, then you're going to end up with huge performance issues, even just trying to read that data with SAS. These options that can be placed in the live name statement or the data set options will help mitigate performance issues until those columns can be identified for what they are and reformatted appropriately. Number 5 is making sure that the db create underscore table underscore op is set properly, as this will make your queries run faster and your performance will improve. Some examples might be, instead of writing the data from a SAS data set to Hadoop as a text file format, which may be the default, it's best to write it as what your Hadoop administrator would have configured that environment to process as. So if it needs to be landed as an ORC file or an Avro or Parquet or whatever their optimal storage technique is in HDFS. There are many other options, but these are the ones that I've found that will have the quickest impact. We're going to break these down a little bit. So let's talk about this 32,767 character string issue. This slide really talks about that in a little more detail. The dba SAS type equal in your SAS code. This is in case you want to make changes to one column at a time. The dbmax underscore text equal allows you to make a blanket statement in your live name statement. Using the dbmax underscore text will affect all columns in that particular read step of the data, and the result then would be an improvement in your performance when reading that data from Hadoop using a SAS technique. So even if it's a proc print or a proc tabulate frequency and so forth. You can also apply the compress equal yes. What this will do is adds an additional step for the compression and decompression when reading and writing. So it could be a trade-off as to whether you get a real benefit here or not. But it's worth doing a performance test just to see if you do notice any variations. Again, a reference to the data types for Hadoop. It's important to make sure you understand what data types are existing in the Hadoop cluster, in the Hive tables, and make sure that those formats are compatible with SAS. Otherwise, you could get unexpected results in column sizes and date formats and such. I encourage you to review the data types for Hadoop section of the reference manuals on support.sas.com. That key tip, again, is leverage processing in database at all times if possible. Make sure you understand the functions that are appropriate when using implicit SQL. And then there's a couple of papers that one should consider. And all you have to do is send me an email, and I'll send you the link to that if you're interested. Here are the details for the read method option. This sometimes can make a difference in the performance. Instead of using the default JDBC driver, you can use the HDFS interaction, and sometimes you can receive a performance improvement. Here are the details from the support.sas.com site for the DB Create table options. There are examples of how you can place that option in your live name statement and find out from your Hadoop administrator what the optimal format is for storing the tables on the Hadoop cluster. I've also included some tips for writing queries in SQL, how you can debug those queries and limit their execution so that you can test out your in-database processing and read the log messages to make sure that you're processing in database, do your head-to-head timing to make sure that you're optimizing your queries before you expand them out to run on a full-blown big data exercise and interaction using SAS and Hadoop. This is the proc and data step version of that same concept of query writing, except in this case, it's techniques for optimizing your environment so that you get the best performance possible. But remember, do these things on smaller sets of data so that you can test them out, do some head-to-head, and then when you turn it loose on the larger set of data, you will already have optimized your code so that it will perform the best possible because of the large size of the data. Configuration is key. In one of the earlier segments, I talk about how SAS interacts with Hadoop. I talk about configuration files and the jar files. They have to be on the local machine where the client environment is interacting with Hadoop. And they have to be compatible with the name node on the Hadoop cluster server. A collaboration between you and the SAS and Hadoop administrators will be key so that you're aware of the environment and its status so that you aren't reporting errors to the team where it's really just a maintenance or the environment is down. These are some benchmarking considerations when you're comparing executions and processing to make sure that you're optimizing your environment. Keep that in mind. So you're always doing apples to apples and not apples to oranges when you're comparing process. And of course, if you have any additional questions, there are a lot of self-service items out in our support.sas.com environment. That brings us to the end of this video and the segment of how SAS interacts with Hadoop. This is the best practices session, and I appreciate you spending the time, and thank you for watching. Should you have any more questions, you can reach out to me directly, or you can contact your customer success manager or the account executive, and they would be happy to provide you with additional information.